You're looking live at the International Space Station Flight Control Room. It's Thursday, July 11th, 2013. On board the International Space Station, and here in the room, teams are coordinating closely on activities ongoing 260 miles above the Earth. This flight control team today being led by Flight Director Greg Whitney. He is overseeing the team throughout the day and joined by astronaut Serena Anand, who is serving as the spacecraft communicator, the link between this team and the crew on board the International Space Station. That crew is comprised of 6 members called the Expedition 36 crew. The 3 crew members to the left of the logo in this view have been there the longest. They are enjoying their 105th day aboard the International Space Station since their launch on their Soyuz TMA-08M spacecraft, ISS-34 Soyuz spacecraft, back on March 28th on a single-day launch to rendezvous. They arrived at the station and docked to the Poisk module, which is a mini research module of the International Space Station's Russian segment, and that spacecraft will be their ride home on September 11th. The other 3 crew members, the newest 3 crew members on the right side of the logo, are the crew members of TMA-09M spacecraft. They launched on Tuesday, May 28th. They're enjoying their 44th day in space. They arrived at the station's Rassvet module, the mini research module number 1, which you see labeled there, and they too will remain at that Soyuz station until their return home in November. November 10th is their current targeted return home. The newest crew members, Fyodor Yurchikhin, Luca Parmitano, representing the European Space Agency and the Italian Space Agency, and astronaut Karen Nyberg, will transition to Expedition 37 upon the departure September 11th of the longest 3 crew members aboard the station, Pavel Vinogradov, Alexander Mazurkin, and Chris Cassidy. Those 6 are orbiting aboard the International Space Station, which currently is approaching the coastline of northwestern Africa, the Moroccan coastline, as we see a camera view from the International Space Station looking down at the coastline as the station approaches. The current orbiting altitude of the station is 260 statute miles. And at that altitude and orbital velocity, the station is circling the Earth every 92 minutes. The crew on board is focusing its attention today on, again, on extravehicular activity or spacewalk work aboard the station, preparing for another spacewalk by Chris Cassidy and Luca Parmitano. They conducted a spacewalk earlier this week on Tuesday and are planning to conduct a second spacewalk this following Tuesday, the 16th of July. The planning for that is continuing here by the extravehicular activity team. There's some replanning going on because of their efficiency with the spacewalk the other day. They actually accomplished some of the tasks that were scheduled for this next spacewalk. So some of that's being replanned, and will be the crew will be talking about that amongst themselves when that replanned spacewalk activity is sent up to the crew for review later on. So a busy day of EVA prep and also housekeeping chores aboard the International Space Station for the Expedition 36 crew. Additionally, a little earlier this morning, the mission management team met for its lone meeting this week that encompasses and includes all of the partnership. The IMMT or ISS mission management team is chaired by Kenny Todd for the program. He is the manager for operations and integration for the space station program. Also represented, of course, are all the partners in the ISS program and all of the engineering communities that are associated with making sure all of the systems are running properly aboard the station and all of the planning is in place for all of the future activities that are scheduled for the crew members on board. Flight Director Gary Horlacher serving as the increment lead flight director, along with Todd. There was quite a bit of congratulatory discussions relative to the EVA that was scheduled that was conducted this past Tuesday, and then the upcoming EVA. Looking forward to that and the scheduling and timelining of all of the events associated with that 6-hour planned spacewalk. Also, congratulations were in store for the reboost activity that occurred on Wednesday. That reboost, which was discussed Wednesday, using the automated transfer vehicle thruster jets known as the orbital control system thrusters, was used to raise the low side of the station's orbit, the perigee, by about 3.2 statute miles. That placed the station in the proper orbit for the phasing that's required for future visiting vehicles, not only departing vehicles but also arriving vehicles, including the next Progress supply vehicle scheduled for later this month on the 27th on a planned single-day launch to docking rendezvous, a 4-orbit rendezvous, but also the landing, phasing for the landing of the 34 Soyuz spacecraft, the TMA-08M spacecraft that Vinogradov, Mazurkin, and Cassidy will use to return home on September 11th. The team did not note any major issues aboard the station. There was a false alarm, fire alarm aboard the station earlier this morning, well into the crew's day. The crew wakes up at 1 o'clock every morning, and the fire alarm that was the smoke detector was over on the Russian segment of the station. And again, turned out to be a false alarm after the crew checked everything and conducted its own sniff checks to make sure that the crew did not smell any smoke of any kind on board the station. And these, sometimes with some software reconfiguration, sometimes these smoke detectors do go off on the station. It's not uncommon. It's infrequent, but not uncommon. And of course, it's no different than a smoke detector going off in your house. You want to make sure that everything's okay before pressing on through the timelined activities. Also, for the first time, the European Space Agency control center that's in Oberpfaffenhofen, Germany, just outside Munich, performed a switch over to a newly installed water pump as associated with the water pump assembly on the station. And after that, that was done after a pump replacement was conducted, and that's been shown to be in good working order, and so the station is back to full redundancy on its water processing systems with WPA and a WPA1 and a WPA2 operational. WPA1 typically will serve as the primary instrument for the water processing apparatus, which is part of the elaborate environmental control and life support system aboard the International Space Station. The EVA, or spacewalk, that was conducted early in the week by Chris Cassidy and Luca Parmitano was a 6-hour, 7-minute spacewalk. And following the spacewalk, the crew members began the reconfiguring of their space suits and all of the equipment that will be used, using the same suits for the following spacewalk out of the U.S. airlock Quest. You see Cassidy on Wednesday afternoon continuing his work with the suits to ensure that they are in good working shape to support the EVA once again on this following Tuesday, the 16th. They plan to head outside and continue with some of the activities of preparing the external areas of the station for the future new science module that the Russian Russian Federal Space Agency plans to launch to the station. The Multi-Purpose Laboratory Module, or MLM, is currently scheduled for launch in December, and it will replace one of the other Russian components on the station, the Pirs docking compartment, which is one of the oldest elements of the Russian segment of the station. It was delivered to the station back in September of 2001. It currently has in this view, the Soyuz 34 TMA-08M spacecraft is docked to that Pirs docking compartment. The new Russian laboratory module will actually replace that Pirs docking compartment. It's much larger, but it too has a docking port and also will serve as the exit and entry point for Russian-based spacewalks as well. So there's a number of activities that are required to be conducted to prepare for that via spacewalk, and it's a well choreographed combination of U.S. EVAs and Russian EVAs to prepare some of the cabling on the outside of the station associated with that the arrival of that and connections of that new laboratory. Crew members also will, during the spacewalk, some of the activities being timelined are to check for any interference associated with a starboard secondary power distribution assembly associated with some activity that occurred back in June using the station's robotic arm and the special purpose dexterous manipulator. Part of the tasks robotically was to open the door of that SPDA, and which underneath houses a RPCM, a remote power control module, and it's a demonstration of how robotically activities in replacing some of the ORUs, or orbital replacement units, on the outside of the station can be conducted without having to do a time-consuming spacewalk. And it was noticed that there was a lanyard that looked like it was blocking the SPDM from opening that door associated with that secondary power distribution assembly. So one of the tasks on next Tuesday's spacewalk will be to head over to that area, which happens to be in a translation path anyway, and check the lanyards and also the pip pins associated with that attachment, and then cycle the doors on that SPDA to ensure that they're working properly ahead of future robotics tasks to demonstrate the replacement of some outside ORUs, or orbital replacement units. They'll also remove some multi-layer insulation associated with one of the main bus switching units on the outside of the station as well. And with all of the tasks that are being laid out and not yet quite in a final stage, the spacewalk is targeted to last a little bit more than 6 hours. Is currently budgeted for about 6 hours and 15 minutes. The start time, the same as this week's EVA, scheduled for coverage beginning at 6 Central, 7 a.m. Eastern, and then the two astronauts are scheduled to head out about an hour later with a targeted start time of the EVA just after 7 a.m. Central, 8 Eastern Time. To this point, Chris Cassidy's performed 5 EVAs, totaling 29 hours and 42 minutes, and Parmitano, of course, that was his first EVA this week, 6 hours and 7 minutes. This was the second of what is expected to be 5 EVAs on Expedition during Expedition 36. One already has been conducted back in the middle of June by Fyodor Yurchikhin and Alexander Mazurkin as part of the process of setting up for the arrival of that Russian science laboratory. One of the experiments that was brought in, the Materials ISS experiment, MISSY, that has already been packed away. It was in the crew's timeline on Wednesday to pack that away after it was brought inside following the spacewalk for eventual return home as part of a cargo return, so that scientists can investigate the experiment, which essentially exposes different types of materials to the outside of the space environment for long periods of time. When the crew wakes up each day, usually the first hour or so is devoted to morning inspection around the station. They do some early morning human experiments on themselves, and then they'll gather together for a daily planning conference that occurs with all of the flight control teams around the world that support International Space Station activities. That daily planning conference allows all 6 crew members to gather and talk to their flight control teams, looking at the day's schedule, their early morning daily planning conference occurred at 2:30 Central Time. They also have a second one at the end of each day to review the day's activities and look ahead toward the next day. And once they complete the early morning planning conference, they head off in different directions depending on what's on their work plan. As mentioned, there was some work with the water processing assembly, the WPA, on board the station that was conducted by Luca Parmitano. And of course, exercise is a strict protocol for crew members on board, as well as conducting some interactive events with folks on the ground. The three Russian crew members actually gathered for a question and answer session with some school students who are part of an international youth science group that were gathered at the Russian Mission Control Center. It's a rare opportunity for us to get to watch an interactive event with our Russian colleagues on board. They included that included Pavel Vinogradov, Alexander Mazurkin, and Fyodor Yurchikhin, and that occurred a little bit earlier in the cruise day, just after 3 a.m.
Hello, my name is Ivan Chamov, and I'm from EPFL. I have a question for Fyodor Yurchikhin. What is the feeling to perform biological experiment on board of the ISS, and did you manage to perform the fish experiment, and how did it go?
Thank you very much for this question. And about the fish, the first stage of this experiment, it's happened, I think, a few years ago, and we are only waiting now for second one stage, and I hope it's a progress. This experience come to us. About the other great experience, for example, the Pavel Vinogradov working with crystal, plasmonic crystal is the name of this experience. Very interesting, very specific, and in internet you may check all information about this experiment. I am continued with different, just a little different experiment. The name is Kulonovsky crystal. It's very nice, very interesting too. Unfortunately, this experiment it's located in Russian segment. We are now in Kibo. It's the biggest model in station. It's from Japan. Just people would like to have everything very small and everything very big. This is the biggest model. And I would like to show you one very interesting detail. It's named by former Russian very interesting astronaut Zenibekov effect. Small experiment. Zenibekov first time understand about this in space. Look here, it's changed the direction of rotation anytime. What happened with our Earth? Thank you. Next one. Thank you very much. We are ready for next question.
Good morning to all. My name is Edgar Rincon Gil. I'm from Colombia. I'm representing EPFL from Switzerland. And my question is, you live with other people from different countries and maybe very different cultures. So when you have problems and difference with others, how do you solve them to keep a good mood among the whole crew? Thank you.
Edgar, and this is an interesting question. Thank you so much. I wouldn't say that we have any problem, and because we have a lot of different people from different cultures and different countries. We have prepared about years for this flight together, and we are not different people. We one crew, and all of us is good friends and colleagues, and we just enjoy to be here together and work together. Суд Москвы, МКС, каналист Г1. Как вы нас принимаете?
Hello, I'm Thibaut Kinser from EPFL Switzerland as well. My question is, do you have a common role model that is inspiring you in your mission about the ISS? Thank you.
Could you repeat your question, please, again?
Yeah, my question is, do you have a common hero that is inspiring you in your mission?
We didn't have, and I hope we will not have some strange problem. And I wouldn't say that we are not ready for something special. Our preparation is too long, and we're doing a great job, and it's a very interesting job. Thanks so much.
Здравствуйте, меня зовут Мунин Евгений, я из университета МГТУ имени Баумана. У меня к вам вопрос. Какой была ваша самая сложная работа или самый сложный эксперимент на борту МКС? Спасибо.
Ну, вы знаете, у нас вся работа здесь интересная. Выделить какую-то очень интересную, но достаточно, ну, не знаю, трудно выделить. Какие-то сложные работы, ну, конечно, есть. Например, это выход в открытый космос, это достаточно напряженная такая сложная работа, очень ответственная. Да и вообще все другие эксперименты, которые мы проводим, мы примерно одинаково к ним относимся, потому что ну, что-то сделать хуже, что-то сделать лучше просто не позволяет профессиональная совесть. Мы стараемся делать все отлично, и вот сказать, что что-то, ну, может быть, сложное в том плане, что что-то, может быть, удается сразу сделать хорошо. Поэтому перепроверяем, повторяем, пока не добьемся того результата, который необходим. Спасибо. Пожалуйста, еще вопрос.
Hello, my name is Nick Robbins from the United States. My question is, do you ever get tired of living in such a small space with so few people while living on the ISS? Thank you.
Now it's too many people. It's 6 on the board. 3 is okay, but it's 6 now. And Chris Cassidy, he is astronaut from NASA. He told after when we with our crew come here, in total it's 6. He told us now it's traffic jam here. No, it's not a big problem on station because we are professional. We know our job and we were ready and we wanted this job and we were ready for any difficulties on the station. Thank you.
Hello, my name is Brian Weiniger from the University of Southern California in the United States of America, and it's a pleasure to speak with you today. What I'd really like to know is what seemingly ordinary or simple items or routines do you miss the most while being away from Earth? Thank you.
Excuse me, may you repeat again? What's the routine of such great subjectives for Earth observation?
I'd like to know what you miss the most about Earth, whether it's family, food, or a nice shower.
Oh, thank you. Yeah, of course, it's our family. It's the first maybe, and everybody maybe understood my answer. Of course, we miss about for me example, every evening we with my daughters, with my family, with my wife, we sit on the table and have evening tea. This is great part time in each day for our family. I miss about tea part with my family, for example. Maybe this is the greatest for everybody.
Hello, my name is Shruti Matthews. I'm from the University of Houston in Houston, Texas. Could you tell us some of the things that you were not prepared for on your space missions? And also, could you explain or show us some of the experiments that you're working on now?
Thank you very much, and hello Houston, because Houston is the city for everybody of Russian cosmonauts. It's the city number one in the USA. A lot of training in Johnson Space Center. So I talked about plasmin crystal, I talked about Kolonovsky crystal, and Sasha now working with very nice, very interesting experiment. It's with special camera. It's a lot of spectrometers in these cameras, and he have observation with Earth planet. Unfortunately, it's located again in the Russian segment, but if you give me a chance, and my guys, my friend would like to answer the other questions, I will show you this equipment. Thank you.
Hi, my name is Julia Phelps, and I go to the University of Southern California in the United States. And I wanted to ask, what do you think should be the top priority in terms of missions for the space industry? And what are your thoughts on the current state of the Mars mission? Thank you.
Я думаю, что в космонавтике перспективно любое направление, потому что сама область исследования очень перспективна. Конечно, нам бы хотелось другим планетам, Марсу и к Луне. Наверное, желание всех астронавтов и космонавтов летать больше, летать дальше. Это нормальное, естественное желание человечества постичь что-то новое. Спасибо.
Hello, hello. I'm Casey Meehan, a student at Brown University in Providence, Rhode Island. Hey, it's a pleasure to talk to you. My question is, so traveling any place new, the excitement tends to wear off after a while, yeah? what starts as really exciting and stimulating becomes normal. So do you ever wake up and have a normal day in space? Is that possible? Let me know if you want me to reiterate that.
Excuse me, could you repeat your question again, please?
Yeah, I can do that for sure, yeah. Is it possible to ever do you ever wake up and have a normal day in space? Or is every day as exciting as the first day you came?
Let's go to that. So, what I want to say, I would like to say that at the beginning, I really feel that each day something special, everything is excited, it's true. But of course, when we are here already more than 100 days, it's really like a normal day. I mean, our job inside of ISS, if we have something special like EVA activity, it's not too much, it's not too often here, and of course it's excited for all of us. As I would like to say that observer of Earth, Moon is also excited, and however, how many times I do it, it's still excited for me. And I think I could not say that it's like a normal and nothing special. Our Earth is so excited, and my breathing is almost stopping when I see it. And the same for the moon, the same for stars, and looks from here very great.
That was as it happened just after 3 o'clock this morning, Central Time, Thursday morning. The Russian cosmonauts gathered to talk to a group of international youth students from schools around the world gathered at the Russian Mission Control Center in Korolyov, just outside Moscow. Among the other activities, of course, that crew members perform on board the station, in addition to all of the science investigations, they also obviously have housekeeping chores and in terms of station maintenance and also personal maintenance. One of the activities that crew members are often asked about is particularly Karen Nyberg, one of the newest crew members on board the station, in her 44th day in space now, is how you wash your hair in space in a microgravity environment. Quite a bit of social media activity out there asking questions such as this one, and Nyberg had the opportunity to talk about that and demonstrate just how she does take care of her hair while she's on board the International Space Station.
And that is how I wash my hair in space on the International Space Station. Hi there. I've had a lot of people ask me how I wash my hair in space, and I thought I'd show you how I do it. Let's see. To get started, these are the things I need. A bag of warm water, a little no-rinse shampoo, towel, and my comb. What I like to do is start by just putting some hot water, squirting it onto my scalp, and I have a mirror here so I can kind of watch what I'm doing. Sometimes the water gets away from you, and you try and catch as much as you can. Then I just work the water up through to the end of my hair. And I take my no-rinse shampoo, And squirt it also on the scalp, just a little bit, and rub it in. Again, kind of working it out to the ends. And sometimes I'll actually take my comb to help work it all the way to the ends. And I like to take my towel while I have the shampoo in there and just kind of work it. Because without standing under running water, you kind of need to use the towel a little bit to help get some of the dirt out. I like to follow that by a little more water. It's called no rinse shampoo, but I think it's best if you use a little water with it. It actually feels kind of squeaky clean right now. Now I'll take the dry part of my towel. We use towels for quite a while here, since we have limited supplies. We use them wisely. There, I think that's pretty good. And now as my hair dries, as the water evaporates from my hair, it will become humidity in the air, and then our air conditioning system will collect that into condensate, and it won't be long, and our water processing system will turn that into drinking water. At the end, I just do one final comb through to make sure there are no snarls and snags. And while it dries, I like to let it stay free. I don't put it back in a ponytail while it's drying. And that is how I wash my hair in space on the International Space Station.
And that's Karen Nyberg, flight engineer aboard the International Space Station on her first long-duration voyage in space. She flew a earlier shuttle flight, STS-124, aboard Discovery, Space Shuttle Discovery, that flew back in May of 2008 to deliver the Japanese experiment module, the Kibo Science Laboratory, to the International Space Station as part of that mission.
In CTB 1212?
Affirm.
4. And that's not a guess, that's it, 4.
4 packages, we copy. We're going to get you some more word soon, once we kind of figure out a plan forward.
And that plan could include going into ATV, and if you just tell us which bay there is, we can take some out of there, because we threw a whole bunch away.
All right, Chris, copy y'all. We'll get back to you soon.
The rest of the day for the crew members, again, continues to focus on preparations for the spacewalk that Chris Cassidy and Luca Parmitano will conduct next Tuesday, the 16th. They've been installing new metal oxide canisters in the extravehicular mobility units, as well as batteries. They also are have printed out the procedures on board for the spacewalk, so that they can review those procedures ahead of a conference with their EVA team here on the ground. And they've also begun a cycling of the batteries, the small batteries that actually provide the electrical power to the spacesuits while they are outside. An EVA, a U.S. EVA, begins officially when their suits are swapped to battery power from the plug-in of the equipment lock of the or the crew lock of the Quest airlock aboard the station. So a number of procedural reviews and preparations that the crew members are conducting throughout the rest of their afternoon ahead of that procedure review conference with the team here on the ground. They'll have an evening daily planning conference shortly after 2 o'clock this afternoon with all of the flight control teams, and then they will head to bed officially around 4:30 p.m. and ahead of their wake-up to begin their timelined activities on Friday, with that wake-up call coming at 1 o'clock in the morning. The flight control teams here will have a shift change mid-afternoon and continue the around-the-clock coverage of activities aboard the International Space Station and Expedition 36. And for one reminder, just after the top of the hour, we will have an opportunity to talk with some school students that are gathered here at the Johnson Space Center as part of the Digital Learning Network. So tune in for that just after 11 a.m. Central. But we'll leave you with the day today with a feature package, Destination Station Promise for the Future. It discusses how the station has shifted from being a construction site to a research and exploration site, a laboratory in space for continued research. Until tomorrow, 10 a.m. Central Time, this is Mission Control Houston.
The completion of the International Space Station heralded a shift in focus from current capabilities in human spaceflight to future possibilities. The lessons we've learned working on station have expanded the realm of possible achievements in human health, education, Earth observation, and exploration beyond low Earth orbit.
We're doing a lot of really interesting things that are going to benefit us in that next phase of exploration. Obviously, we're most interested in understanding the human body in zero gravity because we want to go beyond low Earth orbit and explore, and in order to do that effectively, we have to understand what is happening to our bodies.
The unique microgravity environment aboard ISS enables astronauts to conduct advanced studies of human anatomy and physiology that cannot be performed on Earth. These studies range from microscopic biology to the effects of full-body exercises. In the Kibo laboratory, astronauts grow protein crystals that are unaffected by the shaping force of gravity. By studying the resulting structure, dimension, and properties of these protein crystals, scientists can uncover a wealth of information about the human body. One protein crystal has helped scientists understand what causes certain allergic reactions, while another facilitates treatments for diseases like muscular dystrophy. With over 100,000 different proteins in the human body, the wide range of potential biomedical discoveries will be a fundamental asset in helping us understand the microscopic mechanisms of life. In addition to the results of health-based experiments, the advanced tools and equipment developed for ISS also have applications here on Earth. The sensitive, precise technology developed by the Canadian Space Agency for a series of robotic arms has been adapted to perform delicate surgeries here on Earth. Capable of working inside an MRI machine, the NeuroArm makes it possible for surgeons to operate on a patient's brain without the risk of tremors from a human hand. Engineered and constructed entirely from non-metallic parts, the NeuroArm permits precision surgical movements with absolutely no magnetic effects on the arm or interference with the MRI device. This same approach is being used to develop an even more advanced robotic surgical arm called KidsArm for use on the delicate tissues of small children and babies. The ever-changing technological landscape of education now makes it possible to connect students to space via ISS.
The space station is having an amazing educational impact in our country. We recently found that over 40 million students had participated in an education demonstration, an interview with an astronaut, or some aspect of ISS research. And the fact that we've had that kind of an impact is really amazing.
School children around the world can interact with astronauts and researchers in new and interesting ways by calling crew members on the ISS, sending up experiments and robotics of their own design, and even controlling a high-resolution camera in the Destiny Laboratory. While these programs are designed to promote a passion for STEM disciplines, science, technology, engineering, and mathematics in young people, they also illustrate the untold possibilities the ISS holds for the future of education and how lessons can be taught. Beyond its role as an orbiting research laboratory, the ISS also serves as an observation platform, capable of giving us an exceptional view of our home. Unlike imaging satellites with set orbital trajectories, the ISS has a constantly changing view of Earth that enables real-time observation and reporting. Crew members help researchers on Earth track changes in geography and natural formations, observe catastrophic disasters, and document the beauty of nature's phenomena. This bird's-eye perspective of the Earth allows astronauts to map and monitor the world's coral reef and lagoon structures and how they change over time. When a volcano erupts or a tsunami sweeps across the ocean, astronauts have a unique vantage point to observe, photograph, and provide assistance to response teams here on Earth.
There's several things that make Space Station unique for Earth Obs. It's close enough so that you can see detail on the surface of Earth if you want to see the detail, but it's far enough away so that you can see things on the length scale of half a continent.
This never-before-seen image would be impossible without photographers aboard the ISS, whose images of our home are both scientific and beautiful.
People who explore, people who venture into the frontier, will want to share the experience, and the aspect of sharing what this frontier environment is like to those who don't have the opportunity to go there is a huge factor in motivating the imagery that comes down from Space Station.
As commercial enterprises assume the critical role of transporting crew and cargo to and from station, NASA will focus on destinations beyond low Earth orbit. Research on the station is bolstering our understanding of the challenges in sending a human to the Moon, asteroids, and Mars. The human body is well adapted to life on Earth, but leaving the planet for deep space can have some pretty serious consequences. Research on the ISS helps scientists understand dietary and exercise precautions that will be needed to help fight the adverse effects of long-duration spaceflight. The human body suffers from muscle and bone loss and weakening of the heart and immune system in microgravity. Traveling to Mars also presents the challenge of radiation exposure and potentially hazardous Martian dust, threats that are currently being studied aboard the ISS. In addition to the physical health risks, Astronauts also face psychological challenges. Current mission scenarios have travel times of more than 6 months to reach Mars, all while in a cramped environment. Astronauts and cosmonauts spend several months aboard the ISS, which gives researchers an opportunity to study the effects of long duration and closed habitation on human psychological health.
So the ISS is in a gentle environment compared to deep space or compared to a transit to Mars or a near-Earth asteroid. We have to use the ISS while we have it to make sure our life support systems, our propulsion systems, all those things are ready to go the distance to the next generation. And if we use ISS wisely, those are going to make our future missions safer and more cost-effective.
I think the ISS is the greatest human endeavor ever in the history of the world in terms of complexity and the challenges that are brought with that complexity.
Some of the biggest lessons learned from the design, development, and assembly of the International Space Station are those of peaceful cooperation among nations.
It would be impossible for any single country to do what we're doing here on Space Station. But as a team, we're pulling for a higher good, and that higher good is to learn to explore, to learn to push frontiers, to learn to move out. And that's really what cooperation brings us. And I can't think of a better example than Space Station when you look forward.
Humans will continue to explore in low Earth orbit, on journeys back to the Moon, to Mars, to asteroids, and beyond. But wherever we go, the International Space Station is improving our lives on Earth now and cementing our first real international foothold for working and living in space.